We're going to solve a system of equations by graphing. We have two lines here, and we're going to rewrite them in slope-intercept form. So remember, slope-intercept form means that we're going to get y by itself, and then we're going to have it equal to mx plus b, where m is my slope and 0b is my y-intercept. So looking at this first equation, we have 3x plus y equals 5. We want to get it into slope-intercept form, so we need to get y by itself. To get y by itself, we're going to subtract 3x from both sides. On the left side, my 3x's cancel out, and I'm left over with y. On the right side, do not combine these two. They're not like terms. And we want to write our x term first. So we're going to write negative 3x, and then it's going to be a plus 5. So for this particular graph, my slope is going to be negative 3, and we always write it as a fraction, so negative 3 over 1. And my y-intercept is going to have coordinates 0, 5. The second line is x minus 2y equal to 4. And again, I want to get the y by itself, but first I have to get the term that has y in it by itself. So I'm going to subtract x from both sides. I end up with negative 2y equals, and again, these do not combine together. I'm going to write my x term first, so it's negative x plus 4. And then I need to get y by itself. I'm going to divide every term by negative 2. So we end up with y is equal to, and on this term right here, this is my coefficient. So there's a 1 sitting in front of that x on the numerator, and so it becomes positive 1/2 x. And then I have 4 divided by negative 2, which gives me a negative 2. So my slope for this line is 1/2, and my y-intercept has coordinates 0, negative 2. So now I'm ready to graph. So now graphing using the information that I have, I'm going to have 0, 5 is my y-intercept, 0, 5, so that's that point right there. And then I'm going to be going down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. So I have several points going here. I'm going to connect them all using a straight edge, because I'm going to be looking for points of intersection of my two lines, so I want them to be as straight as possible. My second line has a y-intercept of 0, negative 2, so 0, negative 2, that puts me down here. And my slope is up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And there's my second line. And using my straight edge again, I see that I have a point of intersection right here. And that point of intersection looks like the point 2, negative 1. So my solution is the point 2, negative 1. Now I always like to check my solutions, so I'm going to take that point and I'm going to go back into my original equation up here, and I'm going to put in 2 for x and negative 1 for y. So putting in 2 for x and negative 1 for y. Simplifying, I end up with 5 is equal to 5. So that's a true statement, and it checks. Then I'm going to use the same set of points in my second equation. I'm going to check my second equation. So I'm going to put 2 in for x here, negative 1 in for y. So doing my second equation, I end up with 2 minus 2 times a negative 1 equals 4. Simplifying gives me 2 plus 2 equal to 4, and this one also checks out.